Good afternoon, folks. Thanks a lot for spending the afternoon with me here after lunch. I'll try not to bore you guys, and it's hard to stay awake after the lunch. This is my first time in Korea. This is my first time in Seoul. It's a beautiful city, and I'm so excited to be here with you guys. And in the last couple of days, met a bunch of companies here, startups and others, and really excited about the rate of innovation in this country. So really happy to be here, and thanks a lot for spending the time with me here for the next 40 minutes. What I'm going to try to cover in the next 40 minutes is what we have built in Amazon Rekognition, particularly the video capabilities, highlight some of the way to use them, what customers are doing with it, so that when you leave, you'll have a clear idea of if you are dealing with images and video, what sort of solutions, if you have already not built, you need to invest on. With that, let's start with this charter that we have, the mission that we have taken on within AWS with regards to ML. Our charter is to get machine learning in hand of every developer and data scientist and make it easy for you guys to build a product or the technology or even the science artifacts that are essential for your business to grow. Before I jump into the computer vision services, just as a quick refresher, I'm sure all of you are quite familiar with it. Swami talked about it earlier in the morning session as well. Some of the capabilities and how we think about machine learning. As we looked at the market, we wanted to make sure we create a very flexible and an open product. We wanted to support all different type of use and application of machine learning within the AWS stack. So if you look at that, as a result, at the lowest stack, we have what we call the framework or the framework and the infrastructure layer, where we provide easy to build machine learning platform by providing the widest and the deepest set of compute capabilities in the world. We also provide all common frameworks that you might come across, be it PyTorch, be it TensorFlow, MXNet, Keras, Gluon. More recently, we have also added Chainer. We make it very easy for you to run your experiments on these frameworks by making it part of our AWS Deep Learning Army. So all you have to do is single click, install this Deep Learning Army, and all the machine learning framework with all the dependencies are easily accessible to you. The layer above is what we call our platform services. Here, the idea here is that, okay, you could probably build your own platform and manage pipeline and data pipeline and the entire CDCI within machine learning here, or you could just use one of these platform offerings that we have, particularly Amazon SageMaker, and focus only on your experimentation, your model training, your model implementation, and leave out the heavy lifting, the undifferentiated heavy lifting to us. And of course, at the topmost layer, we have the application services, and I'll talk about it a little later. Fortunately, and very excited to tell you that we have, of all the cloud offering that have machine learning today, we have the most number of referenceable customers that are using machine learning on AWS, using AWS in their production pipeline. Now, why is that an important distinction beyond just showing that Amazon is truly customer obsessed? It's important because what it allows us to do is work with customers, get their feedback, and in very strong loop, iterate on our product and improve our product. And you'll see this as I talk through recognition and vision, you'll see that stand out as well. So as I said, we'll talk about the application services stack, and primarily we'll talk about the computer vision capabilities today in this session. So back in 2016, we launched Amazon Rekognition Image. And since then, again, thanks to the customers that have been very deeply collaborating with us, we have added new capabilities, improved our feature set quite drastically, and what we have today is this set of features. We start with object and scene detection. I'll get into a bit more detail what these capabilities are. We do face analysis, we do face recognition. There's a few capabilities of face recognition we provide to you guys. We have inappropriate or unsafe image detection, which is very, very useful for content moderation, particularly if you're dealing with user-generated content. We provide celebrity recognition, and you will see this Jeff's very, very smiley, happy face. I do want to call out, you'll see a bunch of these slides with Jeff's face in it. In Amazon, we are not very proud. We use Jeff's face because it's frugal so that we don't have to pay a celebrity. And then finally, text in image, which is our detection of text from images and video. So let's jump into these features. What is object and scene detection? If I took an image of this room with the lights on, of course, right now I can't see any of your faces. If I took an image of this room with the lights on, Rekognition will tell you this is an indoor, this is a meeting room, this is conference, there are people, there is water bottle, there's bag, maybe there's some computers here somewhere, and we'll be able to call this out without any other training needed. And we provide you a confidence score. Next is face detection. Well, face detection, what we do is, again, if I took an image, it'll find all the faces in this audience, identify it with a bounding box, provide some key landmarks within the face, provide demographic attributes like what is the age range, what is the gender, emotions, whether you're happy, if you're surprised. I can see whether you guys right now might be angry with me. General attributes like what is your face hair, are you wearing eyeglasses, are you wearing sunglasses, are your eyes open? A great use of the eye open from some customers out there, customers who are operating in manufacturing environment and has heavy machineries, when their operators are in front of the heavy machinery, they have a sensor that's taking these pictures. If these operators' eyes are closed in multiple frames, that means they're dozing off, mostly after lunch sessions, right? So as a result, we are able to get them help and get them to say, hey, do you want a break? Or do you need some coffee or something like that, right? A good example of the demographic information could be as people came into the room, if we had a sensor outside, we could very easily tell you how many male, how many female, what is the age distribution of this audience. So again, very easy. If you're building a solution for customer, very easy for you to know who your customer are without having them to fill up a survey, fill in a form, which is extremely, extremely useful. Now, when we started face detection at launch, we supported, I think, 15 faces in an image. And a bunch of our customers from public sector, as well as customers that are managing events and crowded environments said, this is not useful for us. Because we need to know faces when there are hundreds of people, 300, 500 people in a scene. We need to understand who they are and what they're doing. So last year we extended our product now to support hundreds of faces, which means very, very small face. We are able to detect all the attributes, identify the face, and give you information about your customer or the environment that you're trying to manage or track. Next is face search. Within the product, face search manifests in a couple of ways. Number one is face comparison. It's a one-to-one match. You provide two images and we tell you whether the image one, the face one, is same as face two. The second one is a large scale face recognition where given an image, given a face, will recognize whether this individual is in a database of a large collection of faces. And I'll explain this a little bit later. Now again, when we launched, our face recognition was performing at a 1.6, 1.2 to 1.6 seconds for most cases. Our public sector customers came and said that, hey, I want real-time face recognition. Because law enforcement agencies or people that are doing protection at borders and whatnot, they want to be able to know somebody is crossing or somebody is around instantaneously so they can react. Not wait for 5 seconds or 10 seconds, it might be too late. So we now have real-time face recognition where you could find a face against a database of tens of millions of faces. Finally, we added this capability because a lot of customers again came and said, love all these attributes I'm getting, love the fact that you know faces, that you're able to do object and scenes, but guess what? A lot of the images I'm dealing with has text in them, has characters in them, email addresses, phone numbers, street sign, restaurant names. We said, okay, and we solved this by doing text in image detection. What's a great example that came out of launching this capability is that if people are managing warehouses or traffic junctions, now you're able to detect license plate and recognize the number out of the images directly. So we launched Rekognition in 2016, and in Amazon we say we are a day one company, and what it means is that we don't think we have ever done with our product. It's the excitement of the first day of launching a product truly is the way we think about every day of our life. Now, this was very, very true, especially with Rekognition. The day we launched Rekognition, I didn't even spend a minute enjoying all the hard work the team had put in. Customer came and said, "This is awesome, but how about video?" So we looked at video, and most of the providers that talk about video capabilities are essentially image analysis services. Why is that? What they do is they take your video, they extract keyframes. So you decode the video, you extract keyframes from every second of the video, and you pass the keyframe to an image analysis service, and that becomes a video analysis service. Well, there's a problem with that. And the problem is these solutions miss out on the context of motion and time. Why is that important? If you saw me as a set of images, if you see me as a set of video images, more importantly, if you see me as a keyframe in a 60 FPS video, then guess what? If I walk quickly here and walk quickly back, you would only get me in frame where I'm stationary, because you would have lost out on the motion of the context of motion. So we chose to build the product the right way. We said, well, let's truly build a video analysis service, not an image analysis service. And as a result, we are able to use the context of motion, time, and the visual aspect of the video to do a much deeper analysis and give you much higher accuracy results. As you can see, some of the capabilities I just explained to you within image are already available in video. Well, so what's so special about video is that given video has a context of motion, as I said, and time, as I said, we're able to do beyond objects, scene, and concepts. We are also able to detect activities. What are activities? Activities are things like falling, a baby crawling, somebody getting into the car, somebody getting out of the car. These are extremely beneficial and useful depending on the sort of solution you're trying to build. So you could imagine if you're trying to do analysis of a shopper in a retail environment, you could see what product did they pick up, what product did they put down, how did they interact with the store, right? So these are very, very important capabilities if you think about it beyond just a set of frames or images. The same way if you think of person tracking, I am pacing back and forth in this stage, and Rekognition would actually tell you how my movement is and where I came from and where I went. What is even more interesting, because we are continuously using every frame, every bit of the video for the analysis, we could also find out the person even if they get hidden behind a occluded object, which is true for some of those people in the corner, because as I'm walking, here is an angle, they might not be seeing me. But when I re-emerge, they're not surprised. They're like, oh my God, where is this guy coming from? Because they know I exist. Just because I'm hidden, I don't disappear. So the same way, we are able to track an individual even when they're partially or fully occluded within the context of a video. We of course provide the same high quality real-time face recognition capability for video. Where we stand out is we provide all of these capabilities for live stream. Of course, today if you go to our website and you go to our API, the API that's available is face search. But if you need other capabilities, it's very easy for us to add this to live stream as well. We do, of course, inappropriate or unsafe video detection, and I'll talk about these capabilities. And then again, finally, Jeff's very, very happy face in celebrity recognition. Now, though again, as I said, though we use Jeff's face here, the actual product does support hundreds of thousands of celebrities, including some Korean celebrities, as I found out before I came here. So, if you think of video, a lot of people think of video as an archive content, which is true, because most of your video gets stored in some disk and then you want analysis of that video. And we support that. So we support video stored in S3. But we are seeing an emergence of these capabilities which are purely based on live streaming. Be it live streaming for telecast or broadcast, be live streaming for social media, be live streaming for security and surveillance. So we said, let's support this really complex video analytics solution on live stream as well, and we are able to do that. To do that, we do need you to connect your live stream to Kinesis video stream, and then Rekognition acts as a consumer of this Kinesis video stream and provide you the analytics as a Kinesis data stream. So, very obvious slide here, right? So what customers, as we rolled out these capabilities and we started customers kind of using it, what are the key themes that are coming out across all verticals? Well, there is a natural need of improving business safety and security. As I said, if people are dozing off, are people stealing? Are people moving? Are people in areas where they're not supposed to be? In a construction site, you want all your employees to wear hard hat and jackets. Are people there without hard hat and jackets, right? So improving business safety and security is a key emerging theme that's coming out of video analysis. Business operations and productivity is another thing, right? A very, very good example is actually Amazon's distribution center. Right? You see a bunch of robotic things moving around, and then it knows where people are, it can detect the people and work around people so there's no injury. It also knows when to go deliver where. So these can only be done if you have a video analysis solution. A lot of customers are using this to improve customer experience and loyalty. So a customer is watching a video. It could be an ad, it could be a user-generated content, it could be a broadcast content. You knowing what's in this video helps you connect with your customer much easily. And I'll talk about some of the actual production use cases we are seeing today. Finally, we are seeing a lot of improved personal and family security. So home monitoring, your doorbells are now smarter. It could recognize a person as they're approaching. Your office security. And so this is a very, very important thing because all of these smart homes today all have the sensors that already are capturing the data. All we are able to allow you to do is to do analysis of this thing in real time so that you can analyze and respond immediately. So let's look at, I showed you this image-based object and scene detection. Let's look at what does video do in the same context. And as you can see here, because of, again, I'm repeating myself a little bit, but because of this context of motion, we are able to do fine-grained activities like somebody's blowing a candle, which again, it is very hard for you to do if you were just looking at the keyframes of video. The fact somebody is drinking is a very, very interestingly hard problem if you think about it. Because most people, unless you have already had your third drink at the end of the evening and it's alcoholic, we drink quick. So I have a bottle in my hand, I drink, I put it back. That's about 60 FPS. So if you did a keyframe, you would have either got me somewhere like this or this. Now holding a bottle, what I'm doing is not drinking. What constitutes drinking? What constitutes drinking is holding the bottle, putting it into my mouth, letting some liquid fluid go through and bringing it out. Again, this is where I think the context of motion and higher accuracy activity detection allows you to do things that you couldn't do before. If you think of a retail space, the distinction between a customer picking up a book for buying and a shoplifting is very, very fine. And you can only do this sort of fine-grained analysis if you have the full context of video. So let's talk about the product at a bit more deeper level of analysis. Let's talk about how this works. Now, all of you are quite familiar with video as a payload. It's fairly cumbersome, it's large. A 2-hour video could be many gigabytes. So what we constituted is a asynchronous workflow for video analysis. What it means is that you start with a start function. It's called the start label detection, start face search. You provide us the S3 file. We provide you a job ID back as a response. Then, in consecutive calls, you say get label detection with the job ID, and when the job has finished, we'll provide you all the labels back that we found in this video. Now, for label detection, what we realize is that some of you might want to understand these labels as a time series, right? That at time 0, I saw an individual, I saw a computer, I saw a cat, I saw a dog, and some activity. And then, time T1, I saw these things. Or you might want to see what is the most prominent object. That if I did a video of this room, my senses, the most prominent object that come out is person, people, human being. The next prominent activity would come out is sitting. The next prominent activity that chances are will come out is me walking, pacing, right? So we can provide you a projection which is based on the label, and in that case we provide you the label and all the time slots where we find this particular object, activity or scene to be occurring. Next is person tracking. As I said, because we are again the full context of video, we are able to track individuals. We provide you these tracking as a set of kind of key components that you could watch here or see. We have kind of visualized it for you. These cookie crumbs are nothing but the response of our API stylized and overlaid over this video. Same paradigm, same pattern here. You do a start tracking and then you get a get tracking where we provide you at every time slot where is the skeleton frame and where is the head of this individual. Now what is the best part of the solution? We are able to track an individual even if we don't see their face, if we don't see their head, if we don't see their whole body, we are still able to track that individual. Face search, as I told you, we support face search in both archive mode as well as real time. So let's look at the live stream mode, real time. As I told you, you start with publishing your stream to Kinesis Video. Once you publish your stream to Kinesis Video gives you an ARN or an ID. You take this ID and you come to Rekognition and it says create stream processor and you provide us the ID. At that moment, what happens in the background? Kinesis Rekognition Video wakes up, starts pulling every stream that you're publishing to that particular ARN and analyzes it to you and gives you either could provide you a feedback as a Kinesis data stream that you can subscribe to or as a SNS notification. And then when you're done processing the stream, let's say you're doing a live event, when the event is over, you send a stop stream processor and the job ends. The archive mode is very similar pattern. You start the face search and the end result you get a set of face matches against the database. Now, I want to pause here because I want to tell you that when customers are looking at this content, in some of your cases, image and video are not that different, right? Because you have a set of images, you have a set of video, and you want to search across all of them. Hey, tell me all the places where a certain celebrities, tell me all the places where I find this person of interest. So, when you start with Rekognition, you create what we call a face collection. Face collection is nothing but is a collection of faces that you can create, which is uniquely yours as a customer. No other customer has access to this face collection that you've created. You index every face that you are interested in this face collection. We actually, for the face collection itself, don't store the images. We convert these faces into a irreversible deep learning thumbprint, if you may, a vector, and we store the vector, and then you can do large-scale searches against this database of vectors. Again, celebrity recognition on video. A lot of use around media and entertainment. We are able to get a video and provide you with hundreds of thousands of celebrities that we've already indexed in our own internal collection. Very repetitive, very simple, similar pattern, which is you start a particular process and you get the results of the process when the job is over. Let's talk about inappropriate content. A lot of you guys are probably dealing with user-generated content or published content where you're worried about is there inappropriate stuff going in front of your customer. Today, if you have that, the workflow probably constitutes of a human workflow. And it's quite expensive, it's inaccurate, there's a little bit of fatigue associated with it. So we provide this capability called inappropriate content detection, or image moderation, or video moderation as we call it, where we provide you whether a particular content is it suggestive or is it explicit. Now that's useful. That's awesome. That's what almost all other providers do. Where we have taken one more step further, and this is kind of the openness and flexibility of AWS in general, is that we also tell you why we think it is suggestive or explicit. In this case, we tell you we think it's suggestive because we found a female swimwear. Now, if you're creating digital content for a media outlet, for adult audience, this might be an okay thing for you to have in your website. Whereas if you're doing for a kids content, maybe this is not okay. So the idea is we want to give some control back to you so you could have your own internal fine-grained decision making as to why this, how this works and what you want to do with this data. I would repeat myself, same thing, you start and then you do a get. So that's awesome, we have this cool capability, but what's the use of these things? Who are using this? We are seeing very excited to tell you that we are seeing a lot of use from media and entertainment and ad tech. I'll talk about this one example. So this ad tech platform, Vidmob, they built a solution using recognition. Well, what they're doing is that their business is the business of ad video. So they work with brands and companies to do the creatives around video, and then they publish this video to the different ad portals like Facebooks and the Googles of the world, and then they are connected to the ad platform to get the performance metrics of these ads, and then of course the better performance is more revenue for them. So if you think of how this ad space works, is that there's this notion of eyeball on an ad. And what it is that people will start watching a video on an Instagram or a website, and then at some point they'll drop off. They'll just stop the video and they'll move on. So the period of time people are watching the video is called the eyeball on the video. And so what Vidmob did is they took all their ad assets that they had, passed through object detection, person tracking, text detection, and then overlaid that with the eyeball dropping and started to emerge, patterns started emerging as to what is causing people to stop watching video. For instance, they saw when a text density in the video, if a video has a beautiful natural background with kids or ocean and whatnot, and the moment the text density in that video goes high, people are dropping off. So now they're able to use that to tweak the content, tweak the presentation, tweak the creative, and they are seeing double-digit improvement in their engagement. So that's the sort of use we are seeing of video analysis within ad tech. What are the other media companies doing? Well, they are passing all their videos, doing object detection activities, celebrity recognition, moderation, and creating secondary search indexes, which then they're using for searching. So if an editor, if a creator, if a producer wants a video of a certain celebrity or a certain activity or a certain scene, a sunset or things like that, it's much easy for them to search through millions of video in a matter of seconds. What is the other thing they're doing? They're using these attributes as signal for recommendation. So now, if a person watches one video, they're able to say, you will probably like this other video in our archive. Labels as well as moderation labels are getting used to filter content out. So they don't want kids to watch videos with guns in them. So gun as a level, they can filter out. They also don't want kids to watch sexually suggestive or explicit content, so they could use moderation filters, moderation content to filter these out so that the customers have a much better experience without the manually expensive process that they had to go through in the past. Now the best part is that they are seeing a really high use of live streams, be it user-generated content, be it events, be it sports, be it just social live cast, as well as for news, by the way. A lot of these companies nowadays, when there's a natural event happening, a lot of their news feed is coming through people just holding their phone, saying, look at that tsunami, or look at that wave, look at that storm, or look at this lightning. And these live casts are coming into the newsrooms immediately, and it's very hard for the news folks to know what to do with it unless they have the analytic information on top of it in real time. To kind of get into the next level, what is a good implementation of recognition video for one of these use cases? As you can see, customers typically start with a large number of video content. that are stored in S3. You could use Lambda trigger function to call recognition video. Recognition video is already available as a Lambda trigger. Once recognition responds back with the results, that can be stored in DynamoDB or database of your choice as durable store, and Elasticsearch as your secondary index. Now, what you could then do is that if you have a digital asset management or a media asset management function here, you could hook it up here and provide search capability, filtering capability out of the box. Now, this implementation is actually an implementation done by one of our media customers, and it took them less than 8 days to basically have this whole thing in place and start processing the large amount of video and images they had on their archive. The next, of course, common use case, as you could expect, is public safety. It's about recognizing people, it's about tracking people, and then it's about doing this in real time so that the law enforcement officers, the agents, the officers can be then alerted in real time to events that are happening. That, hey, somebody has fallen, right? If you're monitoring a home, knowing that, you know, I have parents at home, my dad and my mom is there, I do have a camera hook there which is connected to recognition video, and I want to know if in the living space or in their walking space if they fall, because it's important for me to know. So that's what we're seeing with public safety. Again, if you look at this use case, basically this is a immediate response use case where there are cameras. City of Orlando is a launch partner of ours. It's a smart city. They have cameras all over the city. The authorized cameras are then streaming the data to Kinesis Video Stream. We are a subscriber to the stream. We analyze the video in real time, search against the collection of faces that they have. These could be their mayor. They want to know if the mayor of the city is in a place. They want to know if persons of interest they want to track. As we find things, we send the response in Kinesis Stream. That could then be used to create a SNS notification and send to pager or a law enforcement agent. We are also seeing the investigative response, right? Some event has happened and they want to know where Ranju was. What did he do? Ranju, before coming to the session, what did he do? Very easy to do today. And then finally, home monitoring. It's very easy. Your doorbells can become smarter. Your home cameras can be very smarter. If you're building some of those devices, have these capabilities inbuilt so you could provide value-added service to your customer. The other applications